Welcome back. Today we're kicking off the NoSQL injection module over on the Portswigger Web Security Academy, named Detecting NoSQL Injection. It's in the apprentice track, so it's beginner friendly, which is exactly who I'm talking to. So before we touch anything, let's read the description, because it tells you more than you'd think if you slow down. It says the product category filter is powered by a MongoDB NoSQL database, and it's vulnerable to NoSQL injection. Our goal is to run a NoSQL injection attack that makes the application show unreleased products. Unreleased just means hidden. Products sitting in that database that the public is never meant to see, and we want to drag them out into the open. That's the whole job. Quick tooling note, because this one needs Burp Suite and the free community edition is plenty, your browser traffic has to run through Burp's proxy. So if you've never set that up, go watch a quick Burp Basics video, get your proxy and Foxy proxy sorted, then come back. Okay, so let me get Burp ready first. I've got Burp open. Two quick things before I browse anything. First, Foxy proxy on, so my browser traffic actually goes through Burp. And second, over in Proxy, the Intercept tab, make sure it says Intercept is off. If Intercept is on, the second you click something, the request just freezes in Burp and the page hangs there loading forever, and you sit there wondering why the site died. Off means traffic flows straight through and quietly lands in HTTP history, which is exactly where we want it. So Intercept off. Right, let's access the lab. And here we go. It's a plain little shop, some products, and across the top a row of category filters. Let me click one. I'll click Gifts. And the page narrows down to just that category, 3 products. So that's our baseline, the normal public view. Hold on to that number 3 because we want it to move later. And that filter I clicked is the interesting bit. When I picked GIFs, the site took that word and dropped it into a query that runs against the database on the back end. So that filter is where our input reaches the database, and that's our way in. Since the proxy was on for that click, the request is already sitting in Burp, waiting for us. I'll head to Proxy, then HTTP history, and there it is. Let me read it quickly because this stuff is invisible until somebody points at it. It's a GET request, the browser asking the server for something. The address is /filter, then a question mark, then category equals GIFs. The question mark means here come the parameters. Category is the parameter's name, the equal sign hands it a value, and corporate gifts is that value. So category is the box our word goes into. Now I'll right-click it and send it over to Repeater. Repeater's the tab where you take one request and fire it again and again, tweaking it each time without clicking around the site every single time. Let me send it once as is, just to confirm we're set up. The response comes back as raw text on the right, which is great for reading errors, but when I actually want to count products, I'll flip to the Render tab, which shows the response like a real page. 3 products, same as the browser. Good, we're wired up. Now before I start blindly chucking characters at this, I want to picture what's actually running on the back end, because that's the thing that makes this click instead of feeling like guesswork. So let me sketch it out. We know it's MongoDB, and here's the key thing about MongoDB. A lot of the time, the back end builds a little JavaScript expression and lets the database evaluate it. So the query behind that filter is probably something roughly like this. So in plain English, find the products where the category matches what I typed, that's the first part, ampersand, ampersand, and where released equals 1. And that second part, the released bit, is the gate. Some products are flagged released, some aren't, and the public only ever sees the released ones. That's almost certainly why we only got 3. Now I'm guessing at the exact shape here. I don't get to see their real code, so don't take this as gospel. But it doesn't have to be exact. It just has to show me where my input lands, which is right here, inside these single quotes around corporate gifts. Because those quotes are the whole game. In there, corporate gifts is text, a string, and the database reads everything between the quotes as one chunk of text. So if I can sneak a quote of my own in there, I get to close that string early and start writing whatever I want after it. Let me go do exactly that. So the classic first move is to throw in a single quote and see if I break something. Just one single quote. The reason is that a single quote is what marks where a string starts and stops. So if the app isn't protecting itself, my quote lands inside that query and confuses it. And whoa, an error. Now if you're brand new, an error feels like failure. It's the opposite. This is the good outcome. Look at what it actually is. It's a 500, an internal server error, and it's specifically a JavaScript error. And that confirms exactly what I just sketched. The database is chewing on a JavaScript expression. My quote broke the string halfway through, and JavaScript threw its hands up. So our input isn't being treated as plain text, it's being run as code. That's the vulnerability waving at us. And honestly, the error is a bit of an overshare. It flat out names MongoDB. And on a chatty one like this, you'll often get the file path and even the address and port the database is sitting on, which is very generous of it. We asked one rude question and it handed back the name of its database and where it lives. For us, that's a free leg up. For whoever built this, that's the kind of error you really don't want pointed at the internet. And quick note on what MongoDB even is, since the lab leans on it. It's a NoSQL database, which just means it doesn't keep things in neat rows and tables like classic SQL. It stores them more like little JSON documents. For us, all that matters is it's Mongo, it's running JavaScript, and our inputs getting through. But breaking it only proves we can jam the gears. The next thing I want to know is whether the app actually evaluates what I send. And you test that kind of backwards. Instead of breaking it, you hand it something perfectly valid and check that it runs clean. Real quick ad break. When I started CyberSec, the hardest part was that everything was scattered all over the place. So I pulled it into one library, 33 modules, foundations through SOC and Blue Team. It is on my Etsy, link in the description. So here's the payload. Corporate gifts, single quote, plus single quote. The single quote closes off the gifts string, and the plus glues it onto the next bit of string. As JavaScript, that's completely valid. So if the server runs it without complaining, that tells us it's genuinely evaluating our input, not just choking on it. One thing before I send, and this is the other classic trip up. Certain characters can't ride in the URL as is. They have to be encoded first. The address bar does that for you automatically, but Repeater does not, so you do it by hand. Or the server reads your payload wrong. You select the payload and hit Control-U, and Burp encodes it right in place. So select, Control-U, send. And no error this time, which is the entire point. We handed it something valid, it ran it, came back clean. So the app isn't just tripping over our input, it's evaluating it as code. That right there is the detecting this lab is named for. The injection's confirmed. So now let's see if we can steer it. If our input's being evaluated, we should be able to feed it a true or false condition and watch the response flip depending on the answer. There's an operator written as two ampersand characters, ampersand ampersand, which means and. Both sides have to be true for the whole thing to come out true. So let me hand it something flat out false. Corporate gifts, single quote, ampersand ampersand, 0, ampersand ampersand, single quote, x. 0 is false, and with an and, one false side drags the whole condition false. Control-U, then send. And the page comes back empty, like my will to live. So it looks like we broke it. Except an empty page is exactly the right answer here. We told it false. False means show nothing, and that's what we got. Now I'll flip just that 0 to a 1. 1 is true. Everything else stays put. Gifts, single quote, ampersand ampersand, 1, ampersand ampersand, single quote, x. Control-U, send. And the gifts products are back. 3 of them. So watch what happened. Same structure, 1 digit changed, and the response flipped from empty to 3. We're driving now. What we type decides what comes back. So here's the move that finishes it, and it's a little subtle. Everything so far has been and. And the trouble with and, if you look back at my sketch, is that released gate, released equals 1, it's still sitting in there. Ampersand, ampersand on the end, quietly filtering out the unreleased stuff. So I can flip my own little condition true all day, and that gate's still standing. So instead of and, I switch to or, written as 2 pipe characters, pipe, pipe. Or only needs one side to be true. So if I or the whole thing against something that's always true, the entire condition comes out true for every single product, category gate, released gate, all of it ignored, and that's how the hidden ones fall out. The payload is gifs, single quote, pipe, pipe, 1, pipe, pipe, single quote. 1 is always true. Select, Control U, send. And we get a 200 back, and with a whole lot more than 3 products. So if we switch back to our lab, we can see that our lab is solved. You can open it in browser so you can see it there too this way. Request in browser, in current browser session, and paste the URL. And the page is packed now, way more than 3. Every category, released and unreleased, including the ones that were never meant to show their face.
So let's walk back through why it worked.
Because this pattern shows up everywhere. The single quote got us a JavaScript error, which told us 2 things at once. Our input reaches the database, and the database is running JavaScript. Then gifs single quote plus single quote came back clean, which proved the app actually evaluates what we send. After that, the false condition gave us nothing, and the true one gave us the 3 gifs items, so we'd proven we control the logic. And switching from and to or with an always true value shrugged off that released gate and pulled the whole catalog, hidden products and all. And you can follow the whole thing in the numbers. 3 at the start, empty when we lied to it, back to 3 when we told the truth, and the full list once we forced it open. But under all of it is one idea. The app took our text and dropped it straight into a JavaScript query it then ran. So the moment we handed it real operators, it just did what we told it. That's all injection really is. And that's the first NoSQL injection lab done. Good job. Please comment, like, sub if you enjoyed the video. See ya, fatty.